Hey everyone, welcome to our last lecture in the ecosystem ecology chapter. What we're looking in this lecture is ecosystems' responses to disturbances. Sometimes ecosystems are going to experience a major disturbance that may alter how they operate. So this could occur over a short or long-term scale. And what ecologists are often interested in is how these disturbances affect the flow of energy and matter through the system. So can an ecosystem resist the impact of a disturbance, and whether the disturbance of the ecosystem can recover to its original state? So we're going to look at today is how scientists study these disturbances, how ecosystems are affected by the disturbances, and how quickly these ecosystems bounce back to their pre-disturbance condition. So it's very important to understand that ecosystems are going to be affected differently by disturbance, and they're going to bounce back differently depending on many different factors, biotic and abiotic, location, all sorts of different factors. Take, for example, 2002, that major Hurricane Sandy that came to shore in New York and New Jersey, caused tremendous amount of ecological damage to the local ecosystem, and then also homes and businesses. So what a disturbance is, it could be a forest fire, it could be a tsunami, it could be a hurricane like Hurricane Sandy, but what it does is it just causes any change in the population size or community. It's also important to point out there could be natural disturbances, but ecologists are really looking at anthropogenic disturbances as well. And anthropogenic are these human-caused disturbances, so logging, deforestation, air pollution, urbanization, global warming, increased CO2 levels, things like that are going to cause disturbances in ecosystems, and we are looking at how we can maintain that balance. It's important to point out, though, that not every ecosystem disturbance is going to be a disaster. To you and I, a forest fire that may be heading towards a housing development is a disaster, but for example, a low-intensity fire might kill some plant species, but at the same time, it's providing a benefit that's where these dead plants are adding nutrients to the forest floor. And if we look at the diagram on the right, usually with no fire, you have these very dense trees that are taking sunlight from the lower plant organisms. Many die, and there's this litter on the floor. But we know that fire is a natural occurrence that actually allows a forest to succeed, and we see a lot more biodiversity when you allow these forests to bounce back and actually experience fire. So when we look at disturbances, we also want to look at an ecosystem's resistance. And what it's doing is, how effective is it to resist the disturbance? So if a disturbance has no effect on the overall flows of energy and matter, we say that ecosystem has a high resistance. On the flip side of that, if we can say an ecosystem is very sensitive if any little disturbance causes a change in maybe a population of an organism. So that will explain its resilience. So an ecosystem is highly resilient if it can return to its natural state rapidly. So the picture we have here, we had a small fire go through this forest, and we can see in a matter of a short time, we already see growth coming back. There are some places that are very fragile, like a desert ecosystem that doesn't get a lot of moisture or rain. Any little disturbance would cause a detrimental effect that maybe vegetation takes years and years to grow back. So we would call that a less resilient ecosystem. Looking at drought, for example, some droughts may last 6 months. If we look at the S and L here, the short term is less than 6 months. L is long term, over 6 months. So looking at these short term droughts, I'm sure it will affect the native vegetation, but it will be able to bounce back. Whereas long-term droughts, we don't know is the natural ecosystem going to be able to bounce back once it finally gets its normal precipitation or rainfall. So that's an example of being highly resilient or less resilient depending on drought. And something that we look at is how we can restore these damaged ecosystems. Again, remember, some of these damaged ecosystems are due to humans, some are natural causes, like Sandy Hook the hurricane. The anthropogenic would be urbanization. So how can we restore this balance in an ecosystem? It was done in the Everglades, and it's still occurring now. Prior to the development of the Miami Fort Lauderdale area, you had Lake Okeechobee. It would drain into the Gulf going south through Florida. But when urbanization started to take over and we started to divert waterways, you'll notice that water started to move towards the East Coast, towards Miami, and we diverted the natural flow of water, which actually, if you've ever been there, the Everglades were drying up. And the Everglades are an amazingly important ecosystem for Florida because they act as a barrier for hurricanes mostly. They will slow down a hurricane as it goes up the continent here. And what was happening is the Everglades were dying off, which in turn threatened the peninsula with those disastrous hurricanes, no protection. So it's been an ongoing process, but through many different works, they've created the natural flow back, and they're seeing a bounce back in the ecosystem. So a perfect example of restoration in a certain area. What ecologists really look at and that really help us understand how an ecosystem functions and how it's resilient to disturbance is looking at how watersheds affect areas. And a watershed is just an area where any water that flows through that area, it could be rainfall, could be any sort of precipitation, snowfall, and then snow melt. The watershed is the area where water will flow through. So looking at closely here, you can see all the forests in this area, the groundwater, anything infiltrated, and all the runoff. This whole area is a watershed. And if we look more closely, we can look at the Las Vegas watershed. And what this is showing you is that any water that falls within this basin is going to end up in Lake Mead. So anything that people are dumping down the storm drain, water that's falling, snowmelt from Mount Charleston, it's eventually going to end up in Lake Mead. So a perfect example of a watershed. And again, the largest watershed in North America is the Mississippi. And we've already talked about this hypoxic zone. So it doesn't matter if you live all the way up here in Montana, eventually it's going to end up in that watershed and into the Gulf of Mexico. And a great example of how ecologists looked at watersheds to study ecology was the Hubbard Brook ecosystem, and this was in 1962. And this is in New Hampshire. And what ecologists did is they took 6 watersheds in the Hubbard Park, and they wanted to look at this area because it's actually very interesting that all the precipitation that falls in this area will either leave through runoff or evapotranspiration. Remember, evapotranspiration is either evaporation from standing water, or transpiration, again, is water loss from plants. And what they did here is they wanted to see the effects of clear cutting, what happened if they didn't plant new material after the clear-cutted area was used. So the area on the left is one watershed, the area on the right is another watershed. They were both 2 separate areas. And what they did here is they obviously clear-cutted it, but then they put down herbicides that didn't allow any vegetation to grow back. And they found out something very interesting. So for several years, there was no vegetation. And prior to this, it's important to note that they checked the nitrites of the 2 watersheds. And the nitrites were the exact same. But it was only 6 months after this clear cutting that they showed significant increases in the stream nitrate conditions. And I'm sure you can guess which ones. It was the ones on the left. Nitrite concentrations increased dramatically, and what they determined was that when trees are no longer present to take up the nitrates from the soil, that nitrates will leach out of the soil and end up in streams that drain in the watershed. And now we already know what happens when there's an abundance of nitrates in a watershed. It increases that algae bloom, and then in turn will limit the amount of dissolved oxygen in a body of water, like a pond or lake. So they learned 2 things, that plants regulate the cycling of nutrients, and that consequences of not allowing new vegetation to grow in a forest is detrimental to the watershed as well. And finally, I'm going to finish noticing that disturbances are okay as long as there's an intermediate levels. So looking at this chart, an area, and we're going to look at species diversity. We want a lot of species diversity. And looking at this graph here, we can see on the y-axis you have low diversity to high, and then frequent the low intensity to high intensity. It's important to note that in an ecosystem that has low amount of disturbances, they don't have a lot of biodiversity. And which makes sense on the right. You assume that lots of disturbances to an ecosystem are going to reduce populations, which makes perfect sense. But it is quite interesting knowing that low diversity also creates that. And what they looked at was in New England. They, on the rocky coast of New England, they looked at algae concentrations. So we're going to look at the line is showing the amount of snail density. And then what they noticed is that areas where there weren't a lot of snails, there were low amounts of algae, different species of algae. It would make sense, again, on the right-hand side, lots of different snails eating all different types of algae. Yes, there's not a lot of algae diversity. But what is interesting is ecosystems have great diversity when every now and then they're disturbed. So what we're looking at here is that populations of best competitors never reach a size that they can dominate because every now and then there's a disturbance. So that also means populations of other species are not going to be driven too close to zero. So as a result, we see high diversity of species in ecosystem that experiences an intermediate frequency of disturbance. So the takeaway from this is disturbances are okay. It means a healthy ecosystem. It means high biodiversity. Just like the example of the small forest fire, we need those to promote biodiversity in a forest. So we learned in this module that disturbances and events can alter population size in a community and an ecosystem. Watershed studies help scientists investigate how disturbances affect ecosystems, and by manipulating watersheds, we can observe how the cycling of water and elements is altered. And finally, other ecosystems show high resilience, which allows them to bounce back quickly to pre-disturbance conditions. And it's also important to remember that the intermediate magnitude favors high species diversity. Remember, you can always check back to the website for resources. You can always contact me if you need anything.